Hey there. Okay, so this is the in-class work for Math 093, section 1.3. And in this section, we had kind of two things that we worked on. In the previous section, we solved one-step and two-step equations. In this section, we're going to start off with simplifying, which is, if you notice from the previous stuff, before we had equal signs in the problems we were solving and getting, y equals some actual number. In this case, we're simplifying, so we're just trying to collect as many of our like terms and get this as small as possible, which we'll use on the more complicated equations that we're going to see later in this section. So we'll do 5 simplifies first, just to get that idea, and then we'll move on back to solve like we did in the last couple sections, but with more complicated stuff. So for simplify, what we want to do is look for like terms. So we can only put things that are like together. For this first example, I have 5 y's there, and I have 2 y's there. So if I have 5 of these things minus 2 of these things, those I'm able to collect, and that would make 3y. My next variable is q. So I have minus 5 q's there and plus 3 q's there. If I have minus 5 of something plus 3 of something, that would give me minus 2 q's. And then the only thing left is this constant, this negative 1. Oops, get back. And so we'll just tack that right on the end. And then that's as far as we can go. There's no equals 0. There's nothing to solve. We're literally just taking this sort of expanded chunk of math and trying to combine it down as small as we can. For the next example, let's see. We have x to the 6's, x to the 7's, and a constant. So let's start, we'll go descending order, so we're going to start with the x to the 7ths. So right here, I have 9x to the 7 plus 6 more x to the 7. So that would give me 15x to the 7ths. For x to the 6th, I have 8 of them right there, and I have 7 of them right there. So 8 of them and 7 of them would give us 15 x to the 6th, and then I got that lone plus 5 there on the end, and that would be as small as we can get that. These next couple of examples, we'll start using some parentheses that we got to clean up, kind of an extra step. So hopefully you remember when we have something out in front of parentheses, that means we're going to distribute that through the parentheses. So we'd be saying 7 times w, 7 times 3. We'll do the same thing here. So 7 times w would give us 7w, and then plus 7 times 3 would give us 21 right there. And then we're going to do the same thing with this negative 6. We're going to distribute it through the parentheses. So negative 6 times w is negative 6w, and negative 6 times negative 3, careful with that double negative, gets us plus 18. And now that we've cleared the parentheses, we will look and see if we can collect some like terms. And we can. Right here we have 7w, right there we have minus 6w, so that would leave 1w, which we usually just write as a plain w. And then for our constants, we have plus 21 and plus 18, and so that will give us plus 39. So that is as simple as I can write this. Again, this doesn't equal 0 or something where I'd be solving. We're just taking a big wad of math and making it into a smaller wad of math. This next one is pretty similar, except that negative is slightly tricky, so let's look at that. So we'll do our distribute again. So 7 times 6 would give us a 42x right there. 7 times negative 5 is going to give us negative 35y. And this you want to treat as a negative 1. That's what that minus is. It still distributes. And the really common error is just to write minus x and then not keep going with it. But it affects that 4y just as much as it does the x. So that should be a minus 4y. And that's the place to look for sign errors. And then we'll look for our like terms. So we got 42x's minus 1x. So that will leave us 41x's. And then we have minus 35y minus another 4y. So that's minus 35 minus 4 would be minus 39y. And then this last one for the simplify, same thing, just a little bit bigger. So let's see where that goes. So we'll go 3 times 5 would give us 15x cubed. 3 times 4 gives us 12x squared. 3 times 2 gives us negative 6x. 3 times 6 gives us 18. And then this minus, and a great way to think of that minus is it's just going to flip all the signs because you're basically just multiplying everything by negative 1. So this would be like negative 2, negative 5, positive 5 in terms of the coefficients. So it just makes all the signs opposite what's showing. So we have our negative 2x squared, our minus 5x, and minus would make plus 5. And now we just look through this stuff and collect up what we can. So for our x terms, looks like that's our only cube right there. So we'll start there with our 15x cubed. For squareds, we have, and notice I'm just counting down in terms of descending powers. It's not incorrect if you do, but this is more standard for sure. So 12x squared, and then we have minus 2x squared, so that will leave us 10x squareds. We have minus 6x and minus 5x, so that's 6 in the whole and then another 5 in the whole, so that would be 11 minus 11x. And then for our constant terms, we have a plus 18 and a plus 5, so 2, 3, so that'd be 23. And if you look, there's no more like terms, cube, squared, linear, constant, so that is as far as we can take that. For this next one, this is where we get into, like we did in 1.1 and 1.2, these ones are going to be solved. They're equations. Equations have equal signs in them, so for this, when we're down to the end of it, we would expect to get x equals some number. So simplify literally means takes the big one in math, make a smaller one, solve x equals something. We're figuring out what value makes that true. So when we're solving with a little bit more complicated problems, like I said in the last one, we would still kind of go reverse order of operations generally, at least for the addition, subtraction, multiplication, division. But something that is really, really important to do is to first collect all your terms, simplify as much as you can on each side of the equal sign. I'll see students start moving stuff around immediately, and it's the moving stuff left and right where you make all the errors. So what we want to do is, like we did on those first 5 problems, simplify this as much as we can, simplify this as much as we can, and then once we have it down to there, then we'll actually start our solve. So let's see where that gets us. For this one, we'd have negative 8x plus 6x, so that will be negative 2x on this side. And then we have plus 2, plus 5, and minus 7. Cool, so that's 7 minus 7. That all just canceled out. That made that really easy. And then negative 2 plus 14 will leave us 12. So you can see it started off as something that looks a little bit more intimidating, but once I simplified it, it's actually a really easy equation. So that's why you always want to simplify first. From the last section, remember if we have something multiplying our x, we're going to undo that with division. So I'll divide both sides by negative 2. And that got x by itself, and that would give us a negative 6. So for this one, again, we want to simplify as much as we can first. So let's clear those parentheses, and we'll distribute this negative 2 across there, so that'll give us negative 2x, and then negative 2 times 5 would give us negative 10 equals negative 5x plus 2. So for this last one, when I was combining this, right, I'm not changing signs because all of this was happening on one side of the equal sign. So I'm literally negative 8 plus 6 made that. This stuff all canceled. I wasn't moving anything over, so I'm not using opposite signs. In this one, this is as simplified as each side gets, so now I'm going to move stuff left and right, and then that's when you're changing sides across the equal sign, that's where you're using the opposites. So careful now. I'll see people up here start going Here's what not to do. I see this a lot, is I'll see people go minus 6x, minus 6x. And that's totally wrong because everything is on one side, so this would be combining. So that's the spot not to get confused. For this one, though, now we do want to cross the equals, so for that I'll use my inverse operations. So since I have a minus 5x on this side, and all things equal, I usually bring the x's over here, and sometimes that seems harder, and I'll leave them on this side, but for this one, if I come this way, I get a positive number, so that sounds pretty good to me. So I'm going to add 5x to both sides. And that makes this 3x minus 10 equals 2. And so that's a little bit simpler. And then I'm going to bring my numbers over to the other side. So I get x's on one side, numbers to the other. So that's a minus 10. And I know I want to work on the 10 and not the 2 because the goal is to get that x right there by itself. So I want to get things away from it. So that's why I'm not bringing the 2 over. So we'll go plus 10 on both sides. And now I have 3x, those canceled, so I'm left with that, equals 12. And let me just come over here and rewrite that. I have a little more room. And then that 3 is multiplying, so we're going to want to divide to undo that. So we'll divide both sides by 3. And x equals 4. Any solve situation, any equation, you can always put the 4 back in there and it should come out the same. If we did it this time, that would make 9, 4 plus 5 would be 9 times negative 2 would be negative 18 on this side. 4 times negative 5 would be negative 20 plus 2. That makes negative 18 on that side. So they came out equal to each other, so we know that answer is correct. The other thing you can do, maybe I'll do it on this next one, is here, if you notice, I did the x's first, I did the numbers second. You can actually write that all in one line, and so I'll show that kind of condensed version down here, which just makes for a little less writing. So for 18, we got some parentheses going on. The only thing that counts right there is that minus in front of this one. These parentheses aren't really doing anything, they're just kind of separating it as two kind of chunks of math that we're going to add. But that minus we do have to do a little bit of work with. So mostly just rewriting this without parentheses. I'm going to drop those, and then I'm going to distribute that negative through. So negative x and minus a negative 3 will make that a plus 3. And then this side I'm just going to rewrite, but without the parentheses, since they're not really doing anything. And then that gives me these two sides of the equation that I can simplify. So again, I'm not crossing the equal sign yet, so this is just like the first 5 problems where we're combining terms. So here I'd have 4x minus x, and that's going to give us a 3x right there, 2 and 3, so that would be 5. So that's a little better from there. And then 7x and 6x, so that's 13x. And then negative 9 plus 4 would be negative 5. From here, we can, I'll go ahead and bring that over. You could bring the x's either way. This is a spot where I was just looking what I did in the notes, so I'll do it the same way as I did in the notes, but this is a spot where I might actually choose to bring the 3x this way just because it leaves me a positive x term without a negative sign, but it really doesn't. It doesn't matter. We get the same answer either way. So let me bring my x's to the left and my numbers to the right. So we'll go minus 13x here and minus 13x here. And then in this same step, I'm going to go, since I'm bringing my x's to the left-hand side, I'm going to bring my numbers to the right-hand side. So I'm going to go minus 5 and minus 5. And it makes it a little bit cleaner to write out. If it's less confusing for you to do it in 2 steps, then absolutely do that. This just leads to a little less writing. So this is 3 minus 13, so that would be negative 10x. And then as intended, plus 5 minus 5, that canceled. as intended, that cancels. So now my x's are all over here. And minus 5 minus another 5, careful there, that makes minus 10. And then lastly, I have a negative 10 multiplying by x, so to undo that, I would want to divide. So we'll do negative 10 on both sides. That cancels, and we would be left with x equals double negatives. That would be a positive 1. And a couple more here, and they just kind of get, it's the same stuff, just slightly more complicated. So for this one, again, I'd clean up all those parentheses first, get this side as combined as I can, get this side as combined as I can, and then I'll move stuff around. So here, we'll do a little distribute for x plus 4, and then this would make plus 6x minus 60 equals 8 times x, and then that would be a negative 72, and then that's just plus the stuff. Those parentheses are just kind of for show. Don't start moving stuff around yet. Simplify as much as you can. So we got 4x there and 6x there, so that's going to give us 10x. 4 minus 60, and we're all on one side, so we're just combining. That'd be negative or minus 56 equals 8 and 1 would give us 9 x's over here. Minus 72 plus 8 would be 64. And then just like I did last time, I'm going to get my x's to one side. This time I'm going to go this way because that definitely looks easier. So if I'm bringing my x's to the left, I want to get my numbers consolidated to the right. And again, I'll just do that in one step again. So we'll go minus 9x, minus 9x. And then, so that's going to have x's on the left, and so then I'll add the 56 to both sides so that this will be by itself. And so 10x minus 9x, that's great. That makes just a plain x. The 56's cancel as planned. On this side, the x's cancel as planned. And then negative 64 plus 56 should be negative 8. I think there's just one more same basic thing. I think this is just to get you a little more practice in class, but nothing new in the problem. So we'll do 6 times 6 for 36y, 6 times 3 for 18, and then we'll just make sure we get that plus 12 copied. There's our equals. 4 times 2 for 8y, 4 times 2 for 8, and again plus 16 over here, and we'll combine up what we can. So 36y, 18 and 12, that would be 30 over on this side, and then 8y, and then 8 and 16, and that would be a 24 on that side. Scroll this up a little bit. And again, just kind of out of habit, I'm going to move the y's to the left and the numbers to the right. So we'll do minus 8y here, minus 8y there, and then we'll do minus 30 to bring this over here, and minus 30 to balance that out. So 36 minus 8 should leave me 28y. 30's are gone, and the 8y's are gone. 24 minus 30 is minus 6, and then our almost last step, the 28's dividing, so I'm going to want to, the 28's multiplying, so I'm going to want to divide that over. That reduces to have y equals negative 6/28. But as always, with a fraction, if the fraction reduces, then we would want to make sure that we simplify that. So looking at that, it looks like I'm going to be able to reduce out a 2. So just to show how I'm doing that, let me write this 6 as 2 times 3. And I think 2 is the greatest common factor between 28 and 6, and 6 is only 2 times 3, and 3 doesn't go into 28. That's what made me look for the 2. So then this would be 2 times 14. And then from there I can reduce those 2's. Certainly don't need to show that, but you do want to make sure that you get your answer in simplest terms. The other thing in terms of the computer, if you threw that in as a decimal, it will probably mark it wrong because I think that doesn't repeat. I didn't check. But if it's a 1/2, you could put in 0.5 and it would mark that right. But if it's something where the decimal goes on forever and you round it, that will actually make the answer wrong. So make sure to reduce your fractions and then put in your simplified reduced fraction answer for the sake of the computer. Cool. Hopefully that helped with that section.